Hello, this is TechMan88, and this video is on some blast chamber research that I've been doing. And basically, the thing I discovered is that if you remove some of the blocks in the middle right here, it's actually going to destroy a whole lot more blocks. And later in the video, I'll show where I'm actually using this in practice. Now, the reason this came up is because I was talking to my Zuma Games in a YouTube comment section, and he asked how my project was going because he's working on kind of a similar project and he was having trouble with the peripheral blocks not blowing up. So I decided to do a bit more research, and one of the things I tried is, of course, removing some of the interior blocks. And it's on this device, which I showed in some earlier videos. I can demonstrate real quick visually. This is the situation where the TNT is summoned right in the middle of the blocks. And it's like you can observe the radius that explodes right here. And that's, just remember that size. And then I can add one of these commands, which is going to take out the blocks before it does the explosion. And by the way, this is pushing all the blocks at once. Which typically, like, people have said for the longest time that lowers the blast resistance to 0, but it's not quite 0. The blocks actually do have the 0 blast resistance, but there's this attenuation factor that you can look up in the wiki. Now, looking at the wiki, the important thing is this point right here, is there is an attenuation. Like, usually that would be like if you have an obsidian block in front of a ray. This is the ray model. Go look at that real quick. So it does a ray trace along each of these lines, and like if it encounters a block, it's going to attenuate the ray that's going out in a certain direction. So when it's trying to figure out the blocks to explode, it'll start at the center of the explosion and then step 0.3 blocks, and then if it's inside a block, it's going to try to destroy it. But the main misconception that I'm trying to get at here is that, like, the moving blocks, they still use this equation, and it seems to be different from air because there's actually non-zero attenuation even if the blast resistance is 0. I've made a basic illustration of what I'm talking about. So imagine this is the explosion center. Basically, the thing is, if you move it closer to some of these blocks, these rays are going to pass through this block right here, and they will be attenuated. But if you move the explosion back, a lot less rays will actually pass through that. So that's the basic concept. It's like the inverse square law, if you know about that. So the way I've been testing is actually by letting it do its thing and then counting it kills all of the entities at the end, and those would be the number of blocks exploded. So if you look at that, 342 were killed, 333. So that's what I'm using to count, and it should be a pretty accurate count. Now that was without removing any of the central blocks. Now I can remove one central block, and you can see it pop up there real quick. And it's actually going to destroy just about the same number, maybe a tiny bit more. But then now if I remove a 3x3 area, now the count goes way up. It's almost 400. So that's 387, 385, 391. Then I can remove an even bigger area. That's 423, 418, 423. That was 5x5, and then 7x7. It doesn't actually go up anymore after that. Now it's 369, 374, 360. So of course there's diminishing returns because there's an absolute max size for the explosion. I think it's 6.9 blocks radius. But this should show that removing this 5x5 area is actually, this will actually make the yields pretty high. And there might be like 6x6 or 4x4, like I'm not sure, maybe one of those is better, but I didn't really want to try and deal with like stuff half a block over, like something in the TNT half a block over. I actually graphed this out, and the x-axis down here, this is the size of the area, the volume that's removed, and then the y-axis is the number of blocks, the entities counted after it does the explosion. So the 5x5x5 area, that's of course the highest number, the biggest yield, and then 3x3 is a bit less, still pretty good, and then 7x7 is a bit less than 3x3. And then, of course, 1 and 0 are just about the same. And by the data I've collected, this is about 20% more than having all the blocks filled, which might seem like just a trivial amount, but it actually has some benefits in terms of actually doing this in practice. Now, this is how I'm trying to use this in practice. So I have a 3x3 area removed, and I have a couple set of pistons which can push independently. So there's a middle area that can push, and then an outside area that can push. And I'll show that real quick. And this is a work in progress. I've been actively trying to change out pistons, like I might try to remove these or something. Just to try and like lower the blast attenuation for some of the outer blocks. But this is letting me get really high yields out of each TNT. So I'm talking about like the 370 block range. You can see it count here. So this is 320 and this is 382. And it's not totally reliable. There's these blocks left over, so this won't totally work all the time. After a couple minutes running, there's all these blocks left over, which are of course going to be a detriment to the system. But that's what I'm trying to work on now. And this is why I'm not trying to release this as a actual working system yet. I've got a lot of redstone back here to drive the system, but I'm going to start with the end result. So this redstone up here is going to trigger the middle pistons. And I'll stop it for a second just so you can see what I'm talking about. So there's sticky pistons in the center, and the reason for that is because you can have a block up here, and that's going to push all the blocks below it, of course. And the reason that was necessary is because you would have a cobble formation coming in from the side, and you can't have pistons down here, so you need like a flat area. So basically it's going to be like this. This is going to create the flat area down in this region. And this piston layout is kind of funky, of course, but pistons have this problem with quasi-connectivity, and I won't get into that very much, but if you know about this stuff, you'll understand why I needed kind of a weird arrangement. Now that I've covered the piston arrays over here, I'm going to talk about the stuff that drives it. Now it's kind of a complex system of you want to push the middle pistons a couple times, then you want to push all the pistons a couple times, and that's pretty hard to do like if you don't know what you're doing. And the way I'm doing it is with this hopper array right here. So there's one item in this hopper chain, and it can be read out by these comparators and then sent into different lines. The way I have it configured here is to fire 5 times on this line and then fire 3 times on the other line for the central pistons. And this works with this comparator right here, which is on subtract mode. So there's a signal coming out of this redstone torch, which is the main trigger for the whole system. So this will turn off for a brief moment, and that allows the item to flow along the hoppers. But then it also has another signal coming out, which it'll disable this comparator most of the time, but it'll briefly enable it at just the right time, such that it gets the signal out of the comparator to trigger what it's supposed to do. This one is a special one. This is the one that triggers the TNT, and that's why I have these redstone blocks right here, just to separate the signal out. And that comes into the same arrangement here with the comparator with the repeater going to the side of it. That wasn't the best explanation, but if you want to do some kind of sequence of events, I would recommend using hoppers like this. I've gone through a whole lot of different ways to do it, like piston tapes and all that kind of stuff, but this is pretty simple. I mean, it uses a lot of comparators and stuff like that, but for testing, this is definitely the way to go. You can easily add redstone, like right there. I just added another instruction to push down the outer pistons, and I can add a couple more to push down the inner pistons. And it's just gonna work. There's not a lot of trouble. So I'm not going to show a lot more about this. It's trying to fit a spherical peg into a cubical hole, if that makes sense. But it's definitely not ready. There's these blocks that get left over, and that's gonna this column would no longer be active anymore. And if you actually built the system, you would have to remove those manually. But the main thing I wanted to address is that if you remove the inner blocks, that will actually give a much better yield out of a TNT explosion when you're pushing blocks. Because from my research, there's actually this attenuation that happens even if you're pushing the blocks. They're not treated exactly like air. They're treated more like a zero blast resistance block. I'll go through the commands briefly that I use to test this. So this one is the one that fills up all the vacant spaces with cobblestone. And then I have this kind of array back here, and I can move the block around to tell it which command to do. So this would remove a 3x3 area, 1x1, 5x5, 7x7. And after that, it goes into this command. This fills up the cobblestone right next to the pistons back here. So it needs to put cobblestone back here so that it can push stuff. And at the same time, it also removes all the blocks right here on the face of it, so it can actually push it, because this is right at the 12 push limit. Then it puts redstone blocks in behind these pistons, and at the same time it summons a TNT. And then after that, it replaces those redstone blocks back with air, and kills all the items, which is what actually gives the count for the number of blocks exploded. And I think that's actually pretty accurate. I don't think the entities actually have a chance to merge, because the entity is going to appear like right inside the block, and it's too far away from other entities. So yeah. But anyway, even if that's inaccurate, I think I've proven my point. I will provide a world download. This has a lot of other testing that I've been doing, but I think that's okay. And just look at the coordinates that I have here. It's near spawn, -5 and -64. Anyway, this is going to do it for this video. I proposed this challenge a while ago to make the most efficient blast chamber you could for 1.13.1, because the developers really don't want TNT to be in the game. But no matter your opinion on that issue, I think this is a good challenge. It's some very tough stuff. You might want to use like a flying machine to come and clean up these blocks. or you might want to do more research on blast explosion radius. If you have recommendations for a good microphone, I would appreciate that. I'm just using an old webcam to do this, and it makes the S's very loud. But at this point, I'm kind of rambling, so I'm going to end the video here, and thank you for watching, and goodbye.